Hello friends, this video on application of derivatives part 29 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 20. It says of all the cylindrical cans of a given volume, we have to find dimensions which has the minimum surface area. So this is one cylindrical can. I can have multiple cylindrical can like this. If you see, one with more height, less width, the other with more width, less height. So if you see all these, there are some cylindrical cans for which the area is same. Sorry, the volume is same. The volume of this cylindrical can is same. I'll say vol is equal to constant, right? We have to find the dimensions such that surface area is minimum. Correct? So volume is nothing but, we know that volume is nothing but pi r square h, and this is constant. And surface area is nothing but, and that value is constant, and it is 100 also given, 100. Correct? So that is one equation I got. And surface area is nothing but, we know that 2 pi r h plus pi r square. Correct? 2 pi r square by 2 pi r h is this area, the curved area, surface area, and two circles we have 2 pi r square. Total surface area is this. I have to find the dimensions for which surface area is minimum. So I have to find dSA by dr, correct? And I have to make it 0. To find that, I have to convert this equation into a total equation which is in the form of r. H component should not be there. So what I can do, I can get this equation from here where h is equal to 100 by pi r square. Correct? I'll write here in this equation, I'll get h is equal to 100 by pi r square. This is my first equation, if you see. So I'll convert this SA as 2 pi r, h is nothing but 100 by pi r square plus 2 pi r square. So if you see, this equation is totally independent of h. It is totally in form of r, pi cancel. So now I have to find dSA by dr. So that becomes, this is 200 by r, that becomes minus 200 by r square, plus 2 pi r square become 2 pi into 2r, and this is equal to 0. So if you solve this, what you get, 4 pi r cube is equal to 200. Correct? 4 pi r cube is equal to 200, or you get r cube is equal to 50 by pi, or r is equal to 50 by pi to the power 1 by 3. So I got one value of r, but I don't know whether in this case it is max, min, or inflection. I don't know. For that, let me find d square s by dr square. That will be how much? If this is my ds by dr, correct? So this will become I think 200 by r square into r to the power minus 2. So minus 2 multiplication, and this becomes minus 3. Correct? Plus 4 pi r become 4 pi. This is the value. This is nothing but plus 400 by r cube plus 4 pi. And this is always greater than 0, because r is always greater than 0. It is a dimension, and this everything is greater than 0. Since it is greater than 0, this value is minimum value. Correct? Since this is minimum value, I know the value of r now. I can find the value of h now. H is nothing but 100 by pi r square. 100 by pi r square. R is what? 50 by pi to the power 1 by 3 square 2 by 3. If you solve this, you get nothing but 2 into 50 by pi to the power 1 by 3. And you see, everything is in centimeter. So this is also centimeter, and this is also centimeter. So I found the value of h and r so that the surface area is minimum. See, the logic is very simple. In all the questions, something is constant is given, and it is given that something is maximum or minimum. So with one equation I can find this value of h or r something. In the other equation where it is maximum or minimum, I need to find that equation totally depend on one variable only. So in this case, I converted this SA as equation in R only by replacing h with 100 by pi r square. So once I have that kind of equation S in terms of R only, I can find ds by dr, make it 0. I got the value of R, and that R is a critical point, can be maximum, minimum, or point of inflection. To confirm its minimum or maximum, I can just find d double second derivative of S with respect to R, and then I found that this is greater than 0. That means I'm talking about the minimum value. That confirms that it is minimum value, and then I found the value of h, and thus I have h and r. Let's take one more example. A wire of 28 meters is to be cut into two pieces. One of the pieces is made into a square, the other is made into a circle. We have to find the length of two pieces so that the combined area of circle and square is minimum. See, if you see, this is the wire, and the wire length is 28 meter, and we cut this wire into two halves and we make a circle and a square with this. Correct? That is how it is. So let's say I cut this into this half x, and this part is 28 minus x. Correct? Now if I make a square with this, all the side will be x by 4 because the total length is x now, and for this my circumference will be 28 minus x. So my radius here will be 28 minus x by 2 pi. Correct? And here my side will be x by 4. Now the question says what should be the length of the two pieces so that the combined area of the square and circle is minimum. So total area is not, combined area is what? Side square, that is x by 4 square plus pi r square. What is the value of r? 28 minus x by 2 pi square. So this is the combined area, and if you see, this is one equation in terms of x. We have to find the value of areas x such that area is maximum. So dA by dx you have to find here, and that will be equal to x square becomes 2x, 4 square is 16, plus pi into this one will become 2 into 28 minus x pi, and this 2 pi square will be there, and this into minus 1. Correct? That's what it will become, and 2 pi cancel. So this will be dA by dx, and this will be equal to 0 for maximum minimum value of x. So if you solve this, what you get, x will come out to be, you can solve this on your own, or let me solve this, x by 8 is equal to 28 minus x by 2 pi. Correct? Or if you solve this, x will come out to be 28 by 1 plus pi by 4. This is the value of x, but we don't know whether it is a maxima or minima or inflection. So let's find double derivative of a. This is dA square by dx square. That will be equal to, this guy will become 2 by 16 minus, it is 1 by 2 pi into 28 minus x will become 28 minus 1. So if you see, this is nothing but 1 by 8 minus 1 by 2 pi, and it is always greater than 0. Correct? This is greater than 0, that means I am talking about minima, and that is what the question is asking. So my value of x I know. If my value of x is there, so the length of the wire is nothing but this guy and 28 minus x. Correct? So value of x is 28 by 1 plus pi by 4. So let's put this like this. This becomes 4. So I'll multiply it 4 here. So this becomes 112 by pi by 4, pi plus 4. This is the value of x, and 28 minus x is nothing but 28 minus 112 by pi plus 4. That if you solve, that comes out to be 28 pi by pi plus 4. So the value of length of the wire is this and this, where this is for square because x was for square and this is for circle. So very simple. What we have done, we knew we have a constant, that is 28 length of the wire. I got x, and 28 minus x is the length of square and circle. I got two equations. I got one equation where I got the area as pi x by 4 square plus pi into 28 minus x by 2 pi square. And I want this equation, if you see, is in terms of x only. I want to maximize the value of area. So I say dA by dx, that is equal to 0. I found the value of x to be 28 by 1 plus pi by 4. Just double check whether it is maximum or minimum. I found that dA square a by dx square comes out to be greater than 0. That is, I'm talking about minimum value. So I found value of x and 28 minus x. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.